Hello and welcome everybody. Good morning, good evening, good afternoon. Hi Jesus, how's it going?
Hi Alex, Happy New Year!
Happy New Year. Yeah.
I'm very well, thank you. Happy to be here.
Yeah.
One more time, a bit later than usual, but lots of things going on.
Yeah. So we had to shift the week 1 week, and we had to change the day from our regular Tuesday to a Monday because otherwise we would have to shift it even more. And so we are sorry that this is not the usual time and it's usual time but not usual day of the week in what was going meta for the previous 11 episodes. But so episode 12, the 1 year anniversary episode, I guess, is a little bit different. But we try to be back on maybe a more our usual slot for the next month if possible. Exactly. But I hope that's okay, and you you tune in nevertheless. If you tune in, would be nice to hear from you now that we've completed the 12-year episode. Well, any thoughts, any feedback, anything is always welcome, and maybe this 12th episode sparks you to give us some of your thoughts, either if you watch this afterwards in the comments on the YouTube video, or if you watch it live. Obviously always open to hear you in chat, so please don't hesitate to type in anything really you'd like to get out to us. So I'm having an eye on, or two eyes on the chat. That's cool. I think we had a great 12 episodes, and I think you posted recently. I need to find this article you recently posted on LinkedIn. This was, maybe I can find this quickly and link it.
And I'll say a couple of words about it, because I guess that's first of all, credit to Michael Hunger, who's been insisting me to do a session on this one, because most of us in this series are familiar with new semantics, but that we have been working on a kind of alternative. Well, not really an alternative, but it's a kind of a different implementation of the same principle. And we thought it would be interesting to look at it, to share it first of all, but also to look at how it's been implemented as a way to to explain another way to interact with Neo4j. And also to welcome any contributions to the code base. So that's the idea. And now we'll give a bit more context on where that comes from and what is it for exactly.
Yeah, I found the link in the meantime, so I shared it. So
perfect.
Yeah.
Good. So I mean, I don't know if you need to give any additional updates or anything coming up, Alex, or maybe at the end, or if you want me to get started, I'm happy to share my screen and we can kick it off.
I think we can get started. I can mention the other upcoming things this week or next week when we're finished. So yeah.
Perfect. So
I think we can get going. So today's topic, while you get your screen ready, is importing RDF data into Neo4j Aura with Python and RDFLib. So sounds to me, and as usual, I got this topic 10 minutes ago. But it sounds more like a hands-on. All of these episodes have been very hands-on, and we explored some technical background and some theoretical background rather, and some explanation, and then went into the technicalities and into practice and hands-on. But importing RDF data sounds very. We don't explore. I mean, maybe you. I mean, I guess you can tell. To me, it sounds like we have some data. We're gonna get it in a graph database.
Exactly. And can you see my screen first thing?
Yes, here it is.
Just make sure that it looks all good. Perfect. So as usual, I'm going to give a little bit of an introduction on slides, and then, like you say, we'll jump into the code and we'll get our hands dirty as usual. But the idea is, the title, I mean, maybe some of you who are in this space, who work with RDF and Python are familiar with this RDFLib package. we'll work with it, and we'll show how we have extended to be able to interact with Aura. And let me tell you where this all comes from. So I was saying that what we know, what we're all familiar with, and I assume, probably it's not crazy to assume after 11 episodes that most of you are familiar with Neosemantics here and NTNS. So this is a library that has been, a Neo4j extension that has been around for years now, and that helps us precisely with this problem. I mean, it's importing RDF into Neo4j. And in the process of importing RDF into Neo4j, solving the problem of translating this triple-based representation in RDF into a property graph representation. So that's what we all know and love, of course, don't we, Alex? I would say that it has a limitation, and let me explain what I mean by that. So Neosemantics is implemented as an Neo4j extension. It's a set of store procedures. So in other words, it needs to be deployed on the server side so that we can then, and I've literally copied a couple of statements from the manual, where you can see that we can, basically we use Neosemantics by calling store procedures, and the syntax in Cypher is called followed by the name of the store procedure. And we do things like, configuring the graph and telling it how to behave when it imports RDF. And then the actual import works in two ways. We can either pass some RDF payload, or we can pass a reference to an external document or RDF generating endpoint. It can be a Sparkle endpoint, whatever. But the idea is that all these calls require this Neosemantics module installed on the server side, which is what this diagram kind of indicates. So the client, the Cypher client, expects some elements to be available on the server side in the form of store procedures. Now, this is an assumption that it's not always valid, and maybe some of you who have requested this kind of alternative are joining us today, because you know that there are deployments of Neo4j where maybe you don't have control over what kind of extensions are available. And one prime example of that is Aura, right? Aura in its current version does not allow the deployment of custom extensions, right? So you can do that in your self-hosted install, but you cannot do it in Aura. But people still want to be able to import RDF data in Aura. So the question is, what do we do? So does that give the right context?
It does, yeah, and that's a question we got a lot, I guess, since the beginning of this episode or this series, and I guess in combination with there being Aura free, an easy and a very accessible way of getting into Neo4j with a graph database as a service. The start is made super easy, but then the limitation, if considering RDF data, is that it's not compatible at the moment, or doesn't used to be compatible, and therefore people were getting ready, getting excited, and realizing, oh, I cannot do this.
Exactly. We've been doing it. And in most of the series that the episodes that we've run here, we've used the Sandbox. The Sandbox is a completely different environment, and that happens to be, it's a temporary instance that you don't really, you just own for a number of days. It's for playing around a little bit, but it's very different from Aura, right? And Sandbox does come with these extensions installed, but that's not, a general assumption. And that's the problem that we wanted to address today. So just to complete the title that we came up with, the solution is based around RDFLib, and in particular an extension to RDFLib, and I'll double click on that in a minute. But it's a Python-based solution. So RDFLib, for those of you who are not familiar with it, is a Python package that deals with RDF in general. So we'll make it possible for you to parse RDF, to generate RDF. It's an RDF management library in Python. So one of the possibilities that RDFLib opens is the extension in a number of ways, and one of them is the type of backend storage. We'll get back to that in a minute, because in the second half of this episode, I want to have just a quick look at the code and the implementation of how we build that. But first, I guess we're going to look at how to use it, right? which is the most immediate, I would say, need. So, but you can find it in the package index as usual. So if you do a search by RDFLib, you will find it as the first match. It's still in an early version, but it already supports the ingestion of RDF in any of the serialization formats. And it's as simple as import. I mean, doing a pip install of the package itself, the RDFLib Neo4j, which has a dependency on RDFLib, so it will import RDFLib with it, and then you're off to the races. I mean, you just need to interact with RDFLib as you would if there was not Neo4j behind, but in any RDFLib type of example, and you just have to specify that you want your graph stored in Neo4j. And we'll see that in a minute in a bit more detail. But the idea is that it's entirely seamless if you are used to work with RDFLib. So you will be working with your library without necessarily knowing that behind the scenes, the data is being stored in Neo4j. That's what this library takes care of. So that's the idea. That's how we've done it, and we want to see it in action. And for that, we built a notebook. So let me stop the presentation and go into my notebook. But before that, we said we're going to be using Aura, so I should have actually kicked it off earlier. So I'm going to start an empty instance just to show that we're working live. I'll copy the password and continue. I'll save the password here on my desktop just to be able to use it. But
yeah, you can also, I mean, now you skipped it over, but it's always there's now with Aura this option to download the file, the login file. So you get the URL, you get the password as well, and you can download it there from the screen you just saw before. And with that, you have it on your local machine, and you don't have to worry about forgetting it or losing it.
Yeah, I'll that's the kind of the right way, the way people should be doing it. I'll probably do it in a quick and dirty way. Just copy the password, use it for now, and at the end, of course, I'll destroy this instance.
Exactly. This is just for demo purposes, not the problem. But if you are planning to use this more often, then it's better not to save it in some text file you might lose again.
Exactly. So well, let's give it a few seconds, because that's the time it takes to get started. But while it does, let's have a look at the notebook. Let me make it a bit bigger to hope it's readable. You tell me, Alex, if it's oops, that's not
you. Yeah.
Am I doing it right?
Yeah, here you go. Yeah, I think it's great. Yeah.
Okay, right. So, well, like I was saying before, all we have to do to begin is just do a pip install. So I'll kick this off. And because there's dependencies defined, it will bring RDFLib and Neo4j. Both drivers will come as a consequence of these installs. So no need to worry about anything more than RDFLib Neo4j. And once this package is installed, all I have to do, like I was saying before, is say, well, I'm going to, and maybe it's worth just for, let me do a quick, well, not even a search. I can even copy this manual on RDFLib. So this is the documentation on RDFLib. If you want to, you can Google that, of course. But basically, I'm doing exactly the same. So I'm doing the installation, and I'm going to take you through some examples. So like I say, if you're familiar with RDFLib, the way you work with RDFLib is you instantiate a graph, and then you parse data into it. So that's exactly the way in which we're going to be working, right? So the only difference, like I was saying before, is that when I instantiate my graph, I'm going to be saying, hey, I'm setting the store parameter to Neo4j cipher. So what I'm saying by that is that I want the backend of my store to be Neo4j and to use the specific implementation that I mentioned that we're going to be seeing later on. But it's the one that we built with RDFLib Neo4j. So if I do that, I'm creating a new graph, an empty graph that's going to be backed by Neo4j. Now, I need to provide some configuration, and in particular, where is that graph located? And in this case, I need the detail from Aura, which hopefully should be running by now. Exactly. So we have Aura here. and we can copy the connection URI. Again, this is probably not the most elegant way to do it, but for this simple example, I'm going to just paste it. And like I say, I will destroy the instance. Hang on, that's instance, and I need to paste the password that I copied earlier. So listen to Alex, not the right way to do it, but for now, let's do quick and dirty here. I'll paste it, and I'm going to install. This is my configuration with basically the URI, the database I want to connect to, my user and my password, and I'm calling the open method, passing the configuration, and if everything looks good, basically it's testing that there's connectivity to that database and that we are ready to go. So we now have a graph, right? And the way we interact with the graph, I'm going to use you as an example, Alex, but I'm following, especially for those of you who are familiar with RDFLib already, I'm going to use very, very similar examples to the ones that you have in the documentation. So RDFLib deals with RDF data, right? So because it deals with RDF data, it expects interactions in the forms of triples, right? So that's what I'm doing in this next section. So I won't go into all those details because we've talked too much about that. But triples, all the elements in a triple, subject, predicate, object, are identified by URIs, are uniquely identified by URIs. And a URI has a namespace component plus a local name. So what I'm doing here basically is I'm defining two namespaces in my vocabulary. I'm going to have individuals, Alex and maybe me afterwards. And I'm going to have a vocabulary as a schema, an ontology, if you want, that adds structural elements to it. Mm-hmm. So I define an individual's namespace by giving it a base URI and then a schema namespace, a vocabulary namespace or ontology namespace. And once I have them, I can create resources, which is the term used to identify URI in RDF. For example, I call one Alex, which is an individual called Alex, identified by this string Alex Erdl. So it's basically a concatenation of the individual's namespace followed by this name. And the same with me. JB is another individual identified by Jesus Barraza. So once I have these individuals, I can generate triples out of them. And that's the fun part. So I'm going to say, okay, Alex is of type person. So Alex is, of course, I'm referring to this individual that has been created here. And RDF type is a standard. RDF is a vocabulary. Type is kind of in our property graph world is a way of giving a resource a type, which would be the equivalent of a label in a property graph, right? Mm-hmm. We're tagging it. We're saying that Alex is a person, right? We could add more of them, actually. We could say, hey, Alex is a person, but he's also a Neo4j employee. And so on and so forth. So as we know, things can have multiple types, or in a property graph, we would say that nodes can have multiple labels. That's perfectly fine. Mm-hmm. Let's add more triples. So I'm saying also that Alex has a name, which is Alex Erdl, which is basically the same as the URI, but I'm giving it a nice, spaced, human readable version of the name. And I don't know, just an additional property. I said Alex has a Twitter handle that I have taken from actually your real one. So these are 1, 2, 3, 4 statements, 4 triples about you that I want to write to Neo4j. That I want to write to my RDF graph, which is what RDFLib does. But I expect the magic to happen behind the scenes. And these writes, which I am effectively doing when I say add a triple to my graph, G is the graph that I created up here, right? So when I run that, I hope everything goes well here. So, and I haven't opened it yet. Let's go back to Aura and go to my, let's go to query. Let's open a browser on my Aura instance. I'm going to find already some information in it. I need to copy once more my password. That's why it was not a good idea, but hey, that's me being a bit, here you go. So if we come here, let's give it a minute to refresh. Hey, we have already some nodes, and interestingly, one is a Neo employee and a person. So let's see what it is. hey, it's Alex. Not surprising. So we have a property graph. I mean, we have the RDF data that we've just created, that we just written to our RDFLib graph, being persisted on the Neo4j side, and we see the translation that we're familiar with. So we see how all literal properties are translated into attributes of the node. So we have the name, Alex,
cool.
Twitter handle, and we have an additional one, which is the URI, which is the unique identifier. And we have seen also how the types have been translated into labels, which is the way in Neo4j, in the property graph, to set the types of individuals, right? So, well, so far so good. Let's add a bit more of information, because the interesting thing, of course, in a graph is when we create connections. So I'm going to just quickly copy it and adapt it to this other individual that I've called JB, and let's do the same with me. So I'm going to have another person. I'm also an Neo4j employee. I have a different name, and I have a different Twitter handle. And finally, why not? Let's add another connection. Let's. I'm very lazy and like the copy paste, but I'm going to say that that Jesus is friend of Alex, right? So these, as you can see, I mean, it's easy to interpret that. This is going to create another node with a set of properties, pretty much like what happened with Alex, but now with Jesus. And ultimately, what we're going to do is create a connection between the two, a triple that connects two objects, JB and Alex, using the predicate, the vocabulary element friend of. So if I rerun this block, it will hopefully not recreate Alex because it's already there. And this will not happen because the translator is aware of the fact that subjects' URIs are unique. So if I'm using the same URI and that already existed in the database, it's not going to recreate it. It will hopefully reuse it. So if we go, this has successfully finished. So if we go back to our instance, we now have see two nodes and a friend of relationship. So if I click on that, we see that we have the two nodes, with very similar structure, the URI, the Twitter handle, and the name, and a connection between the two. So great, right? So
it's pretty cool. Yeah.
What's interesting, and probably this is more visible to the RDFLib practitioners, is that if you look at this code, there's nothing RDF related here. Sorry, nothing Neo4j related here, and that's why I was bringing the manual. So you have an example, and that's exactly what they provide in the manual. So they create an individual, that's Donna in this case. We're saying there's a person, he has a name, blah blah blah, a nickname, a mailbox, blah blah blah. So exactly the same way in which you would interact with RDFLib. I mean, that doesn't change at all. Is what you do, because effectively you're working with RDFLib, except that transparently and by setting these initial configuration parameters, saying that the store is an Neo4j cipher, every change to the graph, every interaction to the graph will be ported and persisted in Neo4j. Two important things here. Well, first one, the interaction in this example has happened at the triple level. What does that mean? It means that every time I run, and we're going to see the code in a minute, but every time I run a graph add, every time I add a triple to the graph, behind the scenes, I'm starting a transaction to the graph, and I'm writing that triple. So that is okay if we're in a kind of transactional situation where we're writing individual triples one after the other. But it probably is not the best idea if we want to import a few thousand or a few 100,000 triples, because I don't want to create a transaction for every triple. I probably want to write a bunch of triples in a single transaction and then commit it at the end, right? So that's what we're going to see in the next example. So here, or instead of me manually adding triples one by one and manually creating them, what I'm going to do is using another feature in RDFLib, which is the parse function, where I only need to set the location of the RDF data that I want to import and the serialization format, and it will go fetch it from there and import it. And this in particular is this one here. So this is a data set that we've used in other episodes in the past, but basically it's a SCOS based. SCOS is a vocabulary, an RDF based vocabulary, with a large taxonomy about software systems that we extracted from Wikidata. You probably remember. I think we used it in the I think it was in the semantic search episode in the 2 or 3. So I persisted that as RDF turtle serialization, and we have loads of elements in here, right? For example, I'm sure there's Neo4j here. So there's an instance representing Neo4j, and probably it has a unique identifier. Remember how Wikidata use these numeric identifiers? We're saying that Neo4j is broader than, has a broader element in this concept, which probably will be something like, oops, I clicked too many times. Yep. So it's a label property graph. So you see how it's a taxonomy, right? So it's a bit hard to follow because this is in theory machine readable data. But the idea is that this large RDF set contains a taxonomy of concepts, as we call them here in SCOS, but basically represents software systems or software technologies. So this is a large file that I can access through this URL. And what I wanted to show is what happens if in my notebook, I want to import a large data set like this one. So I don't want this interaction to happen at the triple level. So I have this extra element, and this is Neo4j, RDFLib Neo4j specific. I can say, hey, and this is a command or a method on the backend store. I can tell the store, hey, backend store, go into batch write mode. And like this, basically what I'm saying is open a transaction, right? All the writes that I'm going to send you now, and these will be thousands of triples coming from this file, keep executing them in the context of the same transaction. And only when I end the batch write, we will commit the transaction. That will also create, not only a single transaction, but also it will chunk the triples in batches, and it will make the exchange with the server way more efficient. So if I do that, and we can run that, and that might take a few seconds, I'll touch in the indexes in a minute. But this is running the input of this large data set. I believe it contains, you can see it here. 15,000, maybe a few more triples, something like that, right? 15,000 triples. So still a tiny data set, but these, instead of running it one by one, it does it in a kind of batched mode. So again, when this is done, and should be done anytime, we can go to our browser. We see that the data is already here. So we have now a concept. I have not deleted, you and me, Alex. Doesn't matter. That's all
okay.
Good. But we now see that we have concepts related through the broader relationship, which is the one that we were using in SCOS. Let me zoom in, and we see things like, there's programming languages, and we have I don't know. I have never heard of Drama, but it seems to be a programming language. George. There's plenty of super, I don't even know how to name that, but there's loads of this is a very rich taxonomy that comes from Wikidata. With
this is only a snapshot of the data. This is by no means
exactly
anyway,
it's it's not necessarily a tree, because it's a taxonomy with it's effectively a graph. But we can do something like, we can explore it and say, okay, let's find a concept, because we're labeling things as concepts in SCOS, that has we see that all the elements have a preferred label. So we can say where C preferred label equals. We think we saw it was Neo4j. I don't know if I'm going to be using the right capitalization, but we can do that. I can return the concept if I've done it right. Good. So there's this node that we saw before. And if I expand it, we see that it links to, we saw before that it was a subclass of graph database or label property graph, but it's also free software and proprietary software. Interesting. So it's again, this is, I mean, the data comes from Wikidata, so it doesn't really matter. The focus here is on the fact that we've managed to import this large taxonomy of RDF into Aura directly. So, I mean, just because I suppose one of the interesting things is that we have offered the possibility of interacting with the graph on the RDFLib side as triples as RDF, but at the same time we have this property graph interface, and we can do cool things like let me do that. So if I take the concept, I want to find the whole taxonomy for Neo4j until we get to a root, and we know that we've got to a root because the root does not have any parent, so it won't have. I mean, that's the way of indicating that. So the idea is the same. So I'm still looking for a concept that's called Neo4j. I will navigate the broader relationship, basically follow the taxonomy until I get to a root, and I know that it's a root because it does not have any more broader than. So we got to the top, and we can store that in we can call it subgraph, and return this subgraph. So we run that. Oh, little detail, of course. I'm not wanting to go just one, but as many levels as possible. So that's what the asterisk does. Otherwise, it was just going one hop. So with this, there you go. So again, the browser doesn't do the hierarchical layout, but we see pretty much here that Neo4j, as we saw, is an instance of graph database, which is a database management system, which is a software system, which is some software, and so on. And so that's kind of the tree for Neo4j. And again, we can interact with that on Cypher and as a property graph on this side, as opposed to in the form of triples as we were doing before. Right. So now what's happened here? And if you remember, let's connect with the introduction of the problem. So there's no extensions installed on the Aura side. Of course, if I do a call db, I mean, there's of course APOC, which comes with it. But if I do dbms procedures, that's not what I meant. So that was procedures. All we can do is here. That's the syntax has changed. It's show procedures. Can't remember. Anyway, that's there must be a way of ways without this, I think. There you go, show procedures. So so we'll see that there's some APOC elements, and that comes bundled with Aura, but there's no neo-semantics right here, as you would expect when you have it on your self-hosted. And so how did that happen? I mean, how did we manage to import this RDF data? Well, let's get back briefly to the slides. So what was happening before in neo-semantics? So in this type of requests, it was up to neo-semantics to go fetch the data, and the translation took place within the neo-semantics and within the server side extension in Neo4j. What's happening here, what's happening when we use RDFLib, is that the translation takes place on the client side. So it's RDFLib, and in particular the extension that we're going to see in a minute. When I do add, that it's transforming this triple into a Cypher statement, because we cannot rely on neo-semantics being installed on the server side. What we need to do is create a Cypher statement that actually stores the RDF data in the form of a property graph. And that's what this Neo4j Cypher indicates. So it's a Neo4j backed store, but it's also Cypher based. So it does not assume that neo-semantics is installed.
I see. So you can run this in anywhere basically. So that's
exactly.
Yeah.
You can run it in a self-hosted as well. If you're running it locally, but you don't have any semantics and you want to use this, all that's happening is that the interaction between my notebook here and my Neo4j instance, Aura in this case, is purely based on Cypher over Bolt. So it makes no assumptions on what type of components may or may not exist on the other side.
Mm-hmm.
And I say that because there's two RDFLib implementations, and that's what we're going to get in a minute now. So the next slide was what's under the hood. So we've seen it in action, briefly. So it's essentially there's not too much to it. I mean, you can just interact with RDFLib as normal, but it's backed in Neo4j. But then what's happening? So what we've done is in the RDFLib Neo4j module, and we're going to jump into that code in a minute, we've extended, let's make that a bit bigger, although it's not super useful here. But one of the things the RDFLib offers is an API, store API, that makes it possible. And actually, why not? Let's look at this, because that will show us. So if I go to my RDFLib, so we see that this description of the store API makes it possible for developers to create multiple backends. So there's some available backends for RDFLib already, and some of them are relational. If you look at Berkeley DB, that's a relational database. So you can create a backend of different types, even based on SQL Alchemy, which is another SQL general relational database module. So you can create the backend that you prefer. So it gives you that possibility, and that's exactly what we've done with RDFLib Neo4j, and that's what I can show you here. Any questions so far? I don't know if there's anything coming up on but we can.
I don't see any questions, but I'm happy to take any questions that are coming. So yeah, if you're wondering, I posted the links to RDFLib and all the other information in the chat, so you should be able to see it. I will post the API link that you just showed in a moment.
Perfect. So right. So this is I was saying the GitHub repository again, Neo4j Labs, that where we've built these implementations. So I'll go straight to the one based on Cypher, but there's this code basically creates two different implementations of the store backend for RDFLib, right? So the first option is implemented relying on having neo-semantics in the server, and then that makes the interaction slightly simpler, and it can leverage all the capabilities already built in neo-semantics. But because there are cases where we don't have neo-semantics, and that's exactly the Aura case, we have an alternative version that's down here. Is it here? Hang on, I'm not following. Initialize the database. Check the following section. No, it's further down. Here we go. So this implementation is the Cypher-based one and assumes no neo-semantics on the server side. So what's happening here? So let's look at the code very briefly. And I don't want to. It's rather simple code, I have to say, but it might be interesting to have a quick look at it. So there's, the store API, which is what the Cypher Neo4j store implementation kind of implements, has a number of required methods. So the open one that you remember tested the connection basically takes care of instantiating the driver and creating a session. So basically, it checks that there's a connectivity and that we can write to the database. But what's more important is the implementation of the add method. So remember how we essentially kept calling the add method and passing a triple as parameters. So the logic here is pretty straightforward. So if you remember, there's two different types of triples. and we can go back to our example. There's the triples that have a literal in the object. So remember, a triple is subject, predicate, and object. So if the object is a literal value, so what we're doing is we're giving an attribute, a property to that node. So if it's a literal, it means that we are giving the node a property, and that happens here as well. But if it's if the third part, if the object is not a literal, but it's another object, then it means that it's a relationship. And that's the case when we were connecting Alex and Jesus, right? So the first check that we need to do to understand what we're doing, if we're creating a property or if we're creating a relationship, is to understand if the object, which is the third element in the triple, is of type literal or not. And that's exactly what happens here. So if the object in the triple, and the triple is, like I was saying, subject, predicate, and object. So if the object is a triple, is a literal, is an instance of literal, then what we're doing is we are creating a property value. But and we deal with the data types and so on and so forth. But remember that ultimately what we're doing is we are creating a cipher that can be sent to the database. So before I look at the specifics of that one, what we're doing is we, in the case, let's say literal, so the URI is the subject, right? So remember that we store the subject, the URI, the identifier of the triple, in the URI property in the node that's being created, and then the rest of the parameters are stored in a resource. I mean, everything in Neo4j, when we store it, we create a node of type resource. We can go to the so all these things are, in addition to being a concept or whatever types we give it, it's also a resource, and that's a way of having a way of merging on a unique identifier, which is the URI. So we can make sure that if there's already a resource with the same URI, we don't want to recreate it, we want to reuse it. And in order to do that, we leverage the merge keyword. So that's what's being generated here. So we are merging on a resource node with a particular URI. So that's the URI that we get here. And then, because we're in the context of a literal property, we're setting a property and with the value. So that's what we're doing, and we're using the format to pass the actual value in for the name of the property and the parameter to the right. But you kind of, without going into too much detail, we see that what we're doing is we're doing a merge and setting a property, right? Yep. If the predicate is RDF type, what we're doing, remember here, is we're setting a label, because types in Neo4j become labels. So the second check that we do here is if it's a type, then we're setting a label, right? And that's what we're doing here. So we're again merging on the same URI, but then we're setting a label, and the type will be, the label will be the actual type that we get in the object. Does that make sense? And finally, if it's not a type or a property or a literal, then we will be creating a relationship. So basically, we're generating the cipher that merges on the from and the to, because that's what we get in a triple. So we get the from, we get the to, and we get the type of relationship in the middle. So that's the from is the subject. We get the to from the object, and we merge the relationship with the property name that we get from the predicate, right? So, again, there's some additional details in terms of how we, instead of running that directly, we can put that in a batch and we execute it if we are in this kind of batched execution mode. But essentially, what we're doing is we're taking the triple that we get and we're generating a cipher statement that basically stores that triple into Neo4j, purely based on cipher without relying on any additional element. So yeah, I think that's probably enough in terms of looking at the code. I don't expect people to be super interested. Probably worth mentioning that there's the other one that we said that relies on neo semantics. So there's a very similar implementation, But if we look at the add implementation of it, interestingly, all it does, and look at the difference in the code. I mean, I don't have to deal with all the exceptions. All I have to do is, hey, I'm going to call ntns import because this method knows how to deal with it. So all I have to do is take my triple and then pass it to that method. But then, of course, that assumes that this method is going to exist in my database, which is not the case in the other. So, right. So there's the possibility of working with RDFLib in Neo4j, both in the case that you have neo-semantics or where you don't. But because today's session was about Aura, where that's not present, we've shown how it's possible to do that in a purely Cypher-based approach. So this RDFLib implementation just takes care of the translation and sends the Cypher over Bolt to Aura, and the interaction takes place just like that. Good. I'm going to take a pause here. I mean, I think that's the core of what I wanted to show today, and that's and we've had a look at the source, so we kind of cover the content for today. So I think I'm going to take a pause here. It's slightly unusual that we're slightly short.
We're a little ahead of time.
Not a bad thing, I suppose. No. But I think it was particularly probably dense in terms of the code and all that. But
yeah.
Any questions from your side, Alex? Does it make sense?
It makes a lot of sense to me. I think it's very interesting, so that you can use this with, like you just said, with neo-semantics installed or no. So I think if you are, user of a particular user of RDFLib, I guess, makes it very easy to just continue using it, and you have you connected to Neo4j graph database no matter what setup you have been given. Let's say you have an IT department that sets up your Neo4j instance for you, and they don't want to install neo-semantics for you, can do it, or if they have installed it for you, you can still continue using it. And I guess it makes it very easy to continue working with in your environment, in your current stack, I guess, where you don't have to learn how to work with Cypher and Neo4j and all of that. So you can just go with it.
And on that point, I'm going to interrupt you. Sorry, Alex, but it's very important because we've decided to start with this Python implementation using RDFLib. But in the same way, there's this package RDFLib in Python. There are packages in Java. There are packages in .NET. There are packages to deal with RDF in JavaScript, right? So and we're talking to different teams that were in, because basically what we've done is we've taken the import part of neo-semantics and we've kind of extracted it from the server side and put it on the client and make it a kind of a client side feature. We've done it with Python, but if you're working with another programming language, the same thing can be done, or even can be created as a I don't know, let's call it a service like a Lambda or something, where we just pass the RDF and it does the translation. So there's multiple implementations, but the idea is exactly what you say. So you can stick to your stack, to what you're comfortable with, and whatever your RDF library, RDF package to interact with RDF, and let that take care of the translation into Neo. So that's in a way kind of a proposal is one possible. Of course, you're free to use it, but it can be used as inspiration to implement something similar in other programming languages. So very, very, very good point there.
Yeah, I think that's very important to make it as easy as possible to combine the two worlds, graph and RDF, and then that's, I guess, the goal of this work. So it's cool. I think you are looking forward to feedback. So if you try this out, if you have any feedback for Jesus, for the team that's working on this, do it via GitHub, I guess, or what would be the best ways to?
I think, the usual. If it's something specific about the code, GitHub is perfect because all these projects are in GitHub. So you can open, of course, an issue, or even better, you can submit a pull request, and any contributions are more than welcome. But as an alternative, there's always the community where you can ask more general questions, and we can point you in the right direction. So any channel is great. Probably much better than the comments on YouTube. Sometimes, we get a YouTube
No,
comment.
yeah. That's probably not the best way.
It is super welcome, but for this kind of more code specific, these type of, it's a lot easier. So yeah, that's absolutely. So feedback is more than welcome, and suggestions and comments, and even share experience of what's it looking like for you. What are we not covering yet, or what have you extended to cover? And yeah, so I hope that the ingest, the fact that Aura is your preferred deployment is not an obstacle anymore for importing RDF data into your graph and working with it pretty much the way you were used to with Neo Semantics. Although, let's make it clear, at the moment this is in early stages, and we've covered the import part, but there's a number of features that's still not supported here. For example, the export part. It sounds like a kind of a symmetric one. It should be relatively straightforward, but this is work in progress. So keep an eye on these, and you should be seeing soon the equivalent part on querying the Neo4j graph and streaming out RDF from it. So what I don't know is if we will get feature parity eventually, because there's a number of things like mappings and other types of things that we can do in Neo Semantics. We'll see. Basically, again, this all comes down to people's interests, and if we see enough interest, we'll consider implementing that, or maybe we'll just keep it more simple and more basic for this type of access.
Makes sense. When you're using this, RDFLib, I guess is used to work with RDF data with not necessarily Neo4j, I guess, but with other tools.
Yeah, exactly.
So can you, and this is maybe a stupid question, but could you use this to work, to do the same, to parallel work, basically say, okay, I have my RDF data, I want to one way goes into Neo4j database because I want it there, and then in parallel it also goes to this RDF tool I used to work with in the past. So just to see for transition,
Absolutely.
maybe.
Yeah. Absolutely. So that's perfectly valid. You could have that would be, I'm going to just sketch it here, but you can say, hey, I have let's call it that's Neo graph that's backed by Neo4j, but then I have let's say triple graph that's backed by, and I'm not very familiar with all the implementations that exist there, but we can look at some of them. Where was that? So if we look at the documentation, that's the API. That's not what I wanted, but we wanted. Hang on. So where was it? So installation, more examples. I have to say that this is, not the best extract. Don't want to be critic, but it's a bit tricky to loading and saving. So let's go here. Further help, source code for developers. I think it's here. Plugin stores. Here we go. So, for example, here you go. So there's a Sparkle store, for example, or different types of the Berkeley one. You want to use a relational, but you can, Oxygraph. I'm not familiar with all of them, but these seem to be HCT. This is another triple-based store. So whichever is your preferred store, you can have your choice here, and you can work in interactively with the two of them. So you can, like you say, I maybe want to have a replica, and everything that goes to my triple store goes to my Neo4j graph, and again, the good thing is that the syntax would be identical. So I would be just writing adds to one and the other. One would be writing to Neo, and the other one would be writing to the triple store. And or you can decide, which triples go to one and which triples go to the other. Whichever logic is the one that makes sense for you. But yes, absolutely, you can have as many as you like, and work with them in the same way you would.
I think that could be interesting, in particularly for users that have been working with RDF previously, but not with Graph, not with Neo4j, and want to see how it looks like, but continue working with their data and then see the advantages and maybe get into the world. So,
yeah. And I mean, we haven't touched on it today, but there's the whole. I mean, if what you're looking is at a migration, of course you can suck data from one and move it into the other, because in the end RDF is a data exchange model. So that's the whole purpose of it. So whether that's to move data out of a triple store into Neo, or maybe query something we've done in the past here, like query a triple store like Wikidata, DBpedia, any of those with Sparkle, string triples out, and use that to populate Neo4j. So that's absolutely fine. I mean, conceptually it's exactly the same thing that we've done here, except that instead of reading from a static file like this one that we were showing here, right? Instead of reading from a static file, you would be reading the output of some execution, whether that's reading from a triple store, running a Sparkle query. So it's again, the important thing is that you are working with RDFLib pretty much in the same way you've been working with all the time, except that by using it as a side effect somehow, your triples are being persisted in Neo4j. So that's the benefit of it.
Yeah, very cool. We have comments from Peter Dimitrios. Performance looks pretty good for basic RDF Python notebook with Neo4j Cypher for doing analysis using Cypher queries.
Well, if that's and I've just realized and that I didn't do it. If that performance looked good, I mean that's nothing compared to what you would get really, because I should have created an index. I mean that's something that I should have done and I didn't. So
okay.
So it's because keep in mind that we're constantly merging in the database, because it's all about when you have triples that refer to each other with the same subject, you have to look it up and reuse it if it exists. So you're doing constant merges, which is lookups and writes. So if you back that by an index, it's going to be a lot faster. And I completely forgot to do that. But essentially, all you have to do, and I have my notes here. But yeah, I mean, kind of interrupted you there, Alex. But the performance is quite decent. So what you would do normally is in a first interaction, you would probably just create an index. That's what I normally do. You create or if a constraint would be even better, but an index is fine. You would say, I want the URI property in a resource to be unique. And once you do that, essentially we can do it automatically creates an index, right, for the constraint. And something like what we just done, I hope it hasn't broken things, but now that should be significantly faster, right? Because it's I don't know if it's still keeping the session, but anyway, there you go. So you see how it was, it took,
it was quicker, yeah.
It still is a small data set, but the performance is decent, right? So keep in mind that we're translating into Cypher, and it's not as efficient as with Neo Semantics, which is a much more kind of lower level type of access, but it's quite decent. So we're looking at taking just getting to a few thousand triples per second, right? So here that's the kind of
I think that's always a good way to do it. I mean, indexes help a lot. Another question from Mark. If you add extra properties with Cypher to a Neo node generated by RDFLib, does the RDF view still work? I guess that's the expert view, which is not implemented.
Absolutely. I mean, the thing is that at the moment, I mean, it won't be a problem at all. So we can just, whatever's persisted on the Neo4j side can be modified pretty much in the normal way. So you can have take a concept and you can delete it. You can add a property. You can do whatever you want. That's absolutely fine. At the moment, the RDFLib implementation is one way only. So it only writes to Neo4j from RDF. So it's absolutely fine. It's a very valid question when we talk about regenerating the RDF or reading RDF out of Neo4j. So maybe in that case, and we'll figure out how the implementation goes, maybe there are some requirements for the information in Neo4j to be serialized correctly, or at least consistently, with the one imported from RDF. But in principle, you can hit the graph from two sides. So you can write to your Neo4j graph from RDF with RDFLib, but at the same time have some cipher scripts from this side, or have another element. That's the whole idea. Neo4j is built to take multiple write throughputs and write workloads through any channel. So it shouldn't be any problem at all.
Okay.
And it kind of makes sense, right? Because sometimes what you do with importing RDF is enriching a graph that already exists. I mean, in this case, we started from scratch with an empty Aura instance, but sometimes, very often, I don't know, you have a graph already and you want to enrich with geographical information, with organization information, with stakeholders. So it's very common that the graph is populated not just via RDF, but through other channels and other ways.
Yeah, that makes a lot of sense.
Very good question.
Yeah. Peter, different Peter. Peter asks, are you working on a book on semantics?
I'm doing work here and there. I mean, it's not specifically on semantics. I mean, on the new semantics. It's and I know that's. I mean, the problem is there's so many hours in the day, but I feel sometimes guilty about the fact that there are some features in neo-semantics and in the different components. For example, this one, that's not sufficiently documented, but I think it was more interesting to run this session, to put out some examples rather than write a proper documentation. So the answer is that I'd love to write a book, and even before a book, I'd love to write some proper documentation or get some help on that. But I'm struggling with that. I mean, this is Alex. Are you going to help me on that?
Writing the book.
Of course, we can co-author that.
Yeah. Let's see. Yeah, it's always difficult. I'm doing the GraphQL book club with Will, and I think Will was very enjoyed the process, but it's a lot of work. So
it is indeed. Yeah.
How many hours you need to pull into this book?
Many nights.
It's a lot. It's a lot. Yeah.
Nights and weekends, and it's a lot.
Okay, Peter, different Peter again, is interesting to have some guidance on use of constraints or just indexes on things don't want to go overboard, but eventual generic tuning techniques for Neo4j could apply. I guess that's true, right? I mean, if it works generally for Neo4j, if it's a good best practice, it will work in this case as well.
Yeah, absolutely. Yeah, in this case, the only, I would say, strong requirement is it's not even a requirement, because you've seen that we've run the session without it. But the thing that will really make a difference is to have this constraint, this index on the URI, because that's the fundamental element when working with RDF. The URI is the unique identifier, and it's the whole RDF graph is based on these notions. So you have to have a fast way to access and to retrieve and to modify them quickly. So that's the only thing. All the rest is it will not have an impact on the RDF input, but it can be beneficial in the usual way, depending on the type of queries or the type of analysis that you run on your data. Indexing can definitely be a useful tool, and you should be. I mean, I would recommend maybe have a look at the manual or the developer guides that your team, Alex, produces. Is probably the best reference that I would recommend.
In the docs on Neo4j, there is lots of important guiding and help, and there is something on indexing which I don't find right from top of my mind, but I'll work it into the description of the YouTube video, so you find it there in a second.
I'm sure the Graph Academy also touches on that, so I know
it does. Yeah. I mean, this is it's everywhere. Cool. I think that's all the questions. Thank you for your questions. Thank you for the participation. Again, if you try it out and give some feedback afterwards, so it would be interesting to hear your thoughts from now you've seen it when you use it, and then we can see what else there is implement, or what's a are you a RDFLib hardcore user and this is the fun feature you'd like to see, let us know, so we can see, okay, this is maybe more important than something else, and we can prioritize, I guess, development.
And I would say also from the point of view, because the whole driver to this, I mean, RDFLib is probably the most popular package to deal with RDF in Python, but the whole driver for this is being able to support, the integration with RDF from Aura. And, if there's something specific that you want on your Aura deployment or your Neo4j Aura graph that's currently not supported or that is only partially, I mean, this is the kind of thing that we also want to hear. And as usual, the code will be on GitHub. I'll probably show immediately after this session. So all the code that we've run, in the absence of a good documentation, at least we'll have the examples.
The example exactly, and the video. I mean, this helps obviously a lot with follow through, at least as a demo kind of a step-by-step guide, and then do it yourself and give it a spin, and that usually helps a lot as well. Yeah. All right. I think that's the end of episode number 12. So 1 year of going meta concluded. So it was really
high five, Alex.
High five, exactly. Really good fun, good series. Looking forward to season 2, as they say.
Exactly.
So I guess we continue with this. Looking forward to next month. Hopefully back on the usual slot, the Tuesday.
First
slot.
Tuesday of the month, right?
So first Tuesday of the month, exactly. So that's what we try to be back on. And yeah, if you are interested in more Neo4j live streams, there's a couple of going on this week and over the next couple of weeks still. So tomorrow I have Tom Azel join me to talk about Wardley maps and how they work in Neo4j. So that's an interesting session, I think, tomorrow afternoon. European time, and on Wednesday we go into the next chapter of the GraphQL book club I just mentioned earlier. Will Lyon, our colleague, has written a book on GraphQL full stack application development, and we are going over each chapter in each session, and this is chapter 7. So if you're interested in GraphQL, join this. If you're interested in seeing how what is a Wardley map? What does a Wardley map work, and how to combine the two with Neo4j? Tune in tomorrow. And with that, yeah, thank you, Jesus. Thank you for the work on all the episodes, specifically on the I guess Neo4j Aura import functionality for RDF. Mm-hmm. That's really cool. And thank you all for watching.
Yes, thank you.
Thank you. Take care. Bye bye.